See to it that you attend the classes regularly. Okay. Yes. To revise what I had done in the previous class, Mahesh, can you tell me what do you mean by time scaling? Yes, Mahesh, can you tell me what do you mean by time scaling? Mahesh is there? Yes, Nandan, can you tell me what do you mean by time scaling? Nandan TV.
Sir, present.
Can you tell me what do you mean by time scaling? Time scaling of a continuous signal or generally a signal. What do you mean by it?
Sir,
What do you mean by time scaling? Yes, Iman Khan, what do you mean by time scaling? Yes, Iman Khan, what do you mean by time scaling? We don't want to waste time. There is no point in being in the class, and I've already told you weekly assignment 1. Those who are not submitted, I've awarded them 0. Those who are submitted, the correction is going on, and soon you will get your marks. Okay, only 31 are there right now. I want everyone to join the class. Those who are not joined the class, see to it that you join soon. Okay. Join the class soon. Yeah, I'll see in 32 right now. Okay, so doesn't matter. Let me share my screen right now. A signal multiplying by the time variable. Okay, so is it greater than 0 or less than 0?
sir, greater than
Greater than 0.
Greater than 0, exactly. So that is what it is required, and you have some quantity, that is the time varying quantity. Let me share my screen right now. Okay, so for example, time scaling. Okay, so when I say time scaling here, so only the scaling operation is with respect to the independent variable there. Okay, for example, x of t, let it be a continuous time signal, and what it says here is only the time variable is multiplied. For example, x of 2t, that is you have here, so x of t by 2. Okay, whatever is it, x of 4t. Okay, x of t by 4. So that is what it has been done here. Okay, so let me say a difference between both of them. So this, you see that the time is being multiplied, so you see that this is the compressed version of it. Okay, so this is the compressed version of the signal of the signal of the signal x of t, of the signal x of t. So this one here represents the expanded version of the signal x of t, expanded version of the signal x of t. Okay, so this is the expanded version of the signal x of t, what I'm writing here. So that is t by 2. Okay, so that is said to be the expanded version of the signal. Next, you have the compressed version of the signal, that is x of 2t. I think in the last class, I had given you a problem to solve it, and the problem was there like this, where you had to find out x of 2t, x of t by 2, and x of minus t, and so on. Okay, so this was for the time scaling property on the independent variable. Okay, so next, what do I have here? In today's class, we are going to have time shifting property. Okay, so in today's class, we are going to understand what do you mean by time shifting property. Now, when I say time shifting here, you will be having the time variable. For example, let me take a signal like this. It is x of t. Okay, this is said to be a signal like this, and it is starting from 0, 1, 2, 3, 4, and 5. So other variables like the time variable, that is after 5, okay, that is said to be having a 0 value. And again, you will be having a time variable that is to the left hand, that is -1, that is -2. So that is on this hand, that is x of this term, which is being present here. Okay, so this is one thing that is being present, where you will be having a value of 1 starting from 0 to 5 here. For example, the value of x of t is said to be 1 once you are having a time that is from 5 to 0. So mathematically, this is how you are going to write it, and 0 otherwise. Okay, so you can see that from the signal at t is equal to 0. Okay, this is the value at t is equal to 0, and this is the value at t is equal to 5. So all the values ranging from 0 to 5 till 5, you are having unity as the value and 0 otherwise. Okay, so any such values where the time takes, it is said to be equal to 0 there. Okay, so now let me go for the first one, which is the signal y of t, that is x of t plus a. Okay, so x of t plus a. Fine. So here a is greater than 0. Okay, so a is greater than 0. Let me take a number for easier understanding, that is x of t plus 2. Okay, if I want to write it, x of t plus 2 here. So if I want to represent this signal, which is x of t plus 2, again I have to write down the graph for it. Okay, a graph for it, where you will be having the signal called as x of t plus 2. So t being replaced by t plus 2. Okay, the value of t, the independent variable here, is being replaced by t plus 2. Okay, so this is what it has been meaning here. So y of t. Okay, y of t equals x of t plus 2. Okay, so that is what the meaning here. 0, this is 1, this is 2, this is 3, this is 4, this is 5, okay, 6, and later on -1, this is -2. Okay, next I have -3. Okay, next this is minus t here, this is t. So that is what do you mean by y of t, that is equal to x of t plus 2. Okay, so now carefully observe here. I want to write x of t plus 2. What do I need to do here? So you have to carefully observe here. When I give t is equal to 0, okay, when I give t is equal to 0, what it happens here? Okay, when I give t is equal to 0, okay, I'll write for one signal t is equal to 0. What is x of 0? That is 1. X of 0 is equal to 1. X of t plus 2. Okay, x of t plus 2, 0 plus 2 here. Okay, what it means here? That is x of 2. Okay, so that is x of 2. Let me, yes, x of 0, that is 1, x of 0 plus 2, that is x of 2 here. Okay, so what is the value of x of 2 from this signal, the original signal? That is 1. Okay, so that is 1 here. Okay, so now, yeah, this is 1. Yes, exactly, this is 1 here. Okay, now what do you mean by the value, that is x of when t is equal to 1? So when I give t is equal to 1, what you will get? X of 1 plus 2, that is
x of 3 is equal to 1.
Yeah, exactly, that is x of 3, that is equal to 1. What is the value of 3 there? That is equal to 1. Again, it goes like this. Okay, so now let me give a negative value now. for your understanding, t is equal to -2 here. Okay, so x of -2 plus 2, x of 0, what is again the value that is equal to 1. And again, if you keep on giving the values, okay, so you can see that it starts from -2. I'm telling you, when t is equal to -3, okay, x of -3 plus 2, that is x of -1, that is the value that will be equal to 0 here. Okay, in all the other values, you can see that you can have the values which are being there up to this point. If you can check by yourself, you are having from -2 to 3. Okay, so this signal x of t, when it is having x of t plus 2, so you can say that this signal x of t is translated, x of t is translated towards okay, towards your left, right? So towards left by 2 units. Okay, so towards left by 2 units. Okay, so that is what do you mean by this term or this signal, what I have written here, y of t, that is what it represents. The representation of y of t, that is x of t plus 2. Okay, x of t plus 2, you can write it like this. From the given signal, where you can write x of t plus 2, you can write this one to be 0, 1 and 2, 3, okay, 4 and 5. So this is -1, this is -2, this is -3. Okay, so you can see that there is a translation or there is a movement of the original signal by 2 units to the left. Okay, so you can see that this is the signal. I'm just writing it. Let me write it carefully. Yes, so you can see that you are having a unit of 1 up to this point here. Okay, so this is what you can write it as -t, and you are having a magnitude of 1 from -2 to 3 here. Okay, so you can see that the signal is shifted towards left by a unit of 2 units. Okay, so signal x of t, the signal x of t is translated or shifted, okay, translated to the left by 2 units, okay. This is what do you mean by time shifting property when a is greater than 0. Okay, so when a is less than 0, how would you write it, right? So how would you write it when you are having the same signal? I mean y1 of t. Yeah, let me write this one as y1 of t here. So now you want to write y2 of t. Okay, you want to write y2 of t, again x of t minus 2. Okay, x of t minus 2, what would happen there? Okay, so if I want to write it, the signal x of t minus 2, I can say that 0, 1, 1, 2, okay, 3, 4, 5, 6, 7, 8, okay. Next, yeah, let me extend it 10 just for your reference, 9, and this is 10. So this is the time unit, that is x of t minus 2, that is equal to y2 of t. Okay, now what happens here? Let me write down the original signal like this, x of t, what it was there, so 0, 1, 2, 3, 4, okay, 1, 2, 3, 4 and 5, up to 5 you had 1 there, and otherwise it is 0 there. Okay, so now what happens here when there is a movement, or when you say that a is less than 0 there? Okay, when a gets a value less than 0, what would be the value? Okay, y2 of t, how would you express a signal there? For example, when t is equal to 0, x of minus 2, that is again 0. When t is equal to 1, that is 1 minus 2 minus 1, that is 0. Next, when t is equal to 2, okay, when t is equal to 2, what happens is x of 2 minus 2, that is x of 0, that is equal to 1. So from 2 you are having 1 here. Okay, so next again at 3 you are having 1. Okay, so if you see that you are having a movement of the time that is there from 3, okay, 4, 5, 6, if you give the values like that, so it is being shifted towards the right by 2 units. Okay, so what you can express here is, so from 2, 3, 4, 5, 6 and 7, up to this point you can say that there is a movement here. Hope you are getting what I'm teaching right now. So this is having a magnitude equal to 1 there. Okay, very much clear about what I'm telling right now. If you can check by giving the values, you can see that the translated signal when A is less than 0, okay, it is shifted towards the right by some A units. Okay, so when A is less than 0, we can say that the signal x of t, okay, the original signal when you have it is translated towards the right by 2 units, okay. So that is what do you mean by the signal x of t, which is translated towards the right by 2 units. So when it is plus a, that is generally what is the representation of it. So you have 2 ways in which you can express a signal when a is greater than 0, when a is less than 0, for y of t when it is having x of t plus a there. Okay, so when a takes a value greater than 0, the signal x of t, okay, the signal x of t is translated towards left by 2 units, when a is less than 0. Okay, when a is less than 0, you can say that x of t is translated towards right by 2 units, So this is what it is, the representation of both of them, where you will be having a greater than 0 and a less than 0 there. Okay, so this is one of the important phenomena. Like once we are going with the standard elementary signals that are there, it is necessary that you practice the time shifting property. Very important property here. When I want to highlight the shifting of it being done, any signal, you'll be having shifting of certain a units. For example, they will just give you a signal and y of t will be having x of t plus 3 like this. Okay, so in the next one, in the coming lecture itself, I'll tell you, you can have this signal also being there. So you'll be having 2 such properties where you will be having time shifting and time scaling property also being written there. Okay, so that is what it has been important. So you'll be getting a signal where you will be having both the properties there. Okay, so it is better that we use a precedence rule there. I'll tell you in the next lectures to come, where you will be coming across the precedence rule of operation. Okay, next, what you will be having is the reflection property. Okay, so third one, it is the reflection property. Reflection. Generally, if I want to take a signal, so similar to this, okay, what I'm writing here, x of t, so that will be having a signal like this, that is unity 0, 1, 2, 1, 2, and this is 3. So this is the time here. Okay, so x of t is being there. So now what do I need to write for the reflected signal? Okay, if I want to write the reflected signal, how do I write it? Okay, so when the reflection of signal is to be carried out, okay, next, changing, first step, what you will be doing, change t to minus t, what you will get, you will be getting the value of t. Once you change it to minus t, you will be getting the reflection about y-axis. Reflection about y-axis. Okay, so what you are going to get here, it is nothing but the reflection about y-axis. So this is what you are going to get. So you are going to get minus 3, minus 2, minus 1, and 0. Okay, so next, x of minus t is the reflected signal. x of minus t is the reflected signal. So reflection takes place about y-axis, okay. So that is what do you mean by the reflection, the reflection being take there in case of y-axis, okay. So you can see that the reflected signal, it is just like the, once you hold a mirror in case of x of t, you will see that the reflection is there along the axis, that is y-axis. So that is there, that is nothing but the x of minus t signal that is going to happen there, okay. If you want to write x of minus t signal, so that is what, there is no change in the magnitude. If you had observed it, there is no change in the magnitude. You can only observe the reflection about the y-axis there, okay. So that is what do you mean by the reflection of the signal, okay. So next, what you are going to observe here. So if you could remember even signal and odd signal, okay, even signal and odd signal there. So let me take an example of even signal. So simple even signal there. So that is x of t. This is having a magnitude 1. So this is minus 1 and 1 generally. And even signal, if you can replace x of t with minus t, so minus t, if you can write it, so that will also have a similar sort of a signal there, okay. X of minus t, that is there, that is 1, okay. So x of minus t, that is there. So what you can observe here is x of t, that will be equal to x of minus t. So that is what is the observation that is being drawn from the given signal there, okay. So in the meanwhile, what you can generally do here is, for an odd signal, what you can see here, you will be having x of t, okay, minus x of t, that will be equal to x of minus t there, okay. So again, x of t, if you want to write it, minus x of minus t there. So that is what you can write it in case of an odd signal, okay. So what are the values that are there? If you get it by multiplying, that is the scalar multiplication, what I told you, or the amplitude amplification that we are talking with respect to the reflected signal. So x of minus t is said to be the reflected signal. So then you are going to call that as a odd signal there. So this is even signal and this one would be the odd signal. So there you will be having the conditions which are to be verified. So if none of the conditions are to be verified, neither it is an even signal nor it is an odd signal there, okay. So that is one thing that you are going to observe, okay. So moving on to the next one, you are having the precedence rule. As I told you, you are going to have the precedence rule in which you are going to analyze the given signal there, okay. So you can write down the precedence rule of time shifting and time scaling there, okay. So precedence rule of time shifting and time scaling. Yes, so precedence rule for time shifting and time scaling, okay. So let me write down here precedence rule for time shifting and time scaling, okay. So precedence rule for time shifting and time scaling, okay. So now let me take any signal y of t that would be equal to x of at plus d, okay. That is any signal x of t would be there. So if I want to have both the signals being verified, how would I generally take it? Like both the signals means both the properties of the signal to be verified, okay. So what I do here when t equals 0, so this is the constants a and b. This is the constants a and b. It can be greater than 0 or less than 0, okay. So it doesn't matter, a and b can be, okay. So it can take a value greater than 0 or it can take a less than 0, the values what I'm referring right now, or b less than 0. I can take such values which are being present here. So y of t, if I want to write it, so that would be given in the format x of AT plus B. So let me take at t is equal to 0, y of 0 there. Okay, so x of, yeah, so that is B. Okay, so that is what do you mean by the signal that is at t is equal to 0 there. So y of 0, that would be equal to x of B. Okay, so this constant term here which is there, so when you are having it, so that would be equal to y of 0. For example, if I want to write y of t equals x of 2t plus 3, I have to verify y of 0, that would be equal to x of 3. The signal should be written in such a way that if you are modeling a signal, you should have the value y of 0 that should be equal to x of 3. Next, what you are going to write here. So once you have this entire term, what do you mean by this entire term here? So x of AT plus B. Okay, so this entire term, what is there? When it is equated to 0, x of 0 that is there. So what would be the value? So y of minus B by A, that would be equal to x of 0. How did I get it? So AT plus B, once it is equal to 0, what would be the time there? So that is minus B by A. Okay, so that is minus B by A, and both the signal has to be having this precedence rule. Like in order to apply precedence rule for time shifting and time scaling. So when I say time shifting, so first you have to have the time shifting property being applied. Second one, you need to apply the time scaling property. So now in order to apply both the rules, I need to have an intermediate signal that is being present there. Okay, so in order to apply both the rules or both the properties of time shifting and time scaling, I need to have an intermediate signal which is to be understood or which is to be verified, which acts as an intermediate operation between both the time scaling and time shifting there. Okay, first I need to do the time shifting. For example, y of t, I need to write it as x of 2t plus 3, 2t plus 3. So an intermediate signal, and intermediate signal, and intermediate signal, and intermediate signal, v of t. What I need to write? V of t, if I need to write it as x of t plus 3. Okay, x of t plus 3. That is what is to be written there. So if I want to write a signal, a similar signal where I have to write down x of t plus 3. So I need to sketch the signal for x of 2t plus 3 then. Okay, so let me sketch a signal for x of 2t plus 3. Okay, yes. Yeah, so x of 2t plus 3. Okay, so let me take any signal, for example. Okay, so the simplest signal is this one, x of t. Okay, minus 1, 1 and 0. Okay, so I need to sketch the signal x of 2t plus 3. So given this signal, so given the signal, so sketch x of 2t plus 3. Okay, you will be given a signal like this initially in the numerical problem. So you need to sketch a signal of x of 2t plus 3, or else you will be given a mathematical way in which you can express a signal, and you need to write down the signal first, and then you have to sketch the time precedence rule for applying the time shifting property and also the time scaling property there. Okay. So let me sketch this one. Okay, x of 2t plus 3. So what do I need to do? I need to have an intermediate signal called as x of t plus 3. So if you can see here, x of t plus a, it takes a form where a is greater than 0. So when t is equal to is having a positive value, so you can see that it is the signal x of t is translated towards the left. Okay, towards the left by 3 units. Okay, so you can add, or you can add, how you can add it? You can have 1, 2 and 3. So this will be having minus 2, minus 1. Okay, and here you are having 0, and here you are having 1 again. This is minus 3 there. So just for your understanding, I'm writing here. So what you can see here is -1 plus 3, that is -2. So you are having a signal somewhat like this. Okay, let me write it here. Okay, you're having a signal like this. So this is equal to 1 here. The signal is being shifted towards right by 2 units. So 1, 2, I'm sorry, 1 minute. Just a moment. X of t plus 3, if I want to write it. So what do I need to do? So -4, -3, okay, -2, okay. This is -1, 0 and 1. This is 2 there, okay. So now I need to translate the signal towards the left by 3 units, okay. So what do I get? So -1 plus 3, okay. So -1, okay, it is being moved towards the left there, so it has to move towards the left. So what do I need to do? I need to take this signal, this is there, so I need to start from -1. So it is being shifted, okay, it is being shifted towards the left by 3 units. So -2, -3 and -4, 1, 2 and 3, okay. So this will have 0 here. Next 0, -1, -2, -3. So 3 will have the 1, that is the magnitude 1, and this one here will be having the -2 will be having a magnitude of 0 there, okay. So this is having 0, okay. So that is what it has been representing, the intermediate signal V of t. If you have not understood it, so you need to translate the signal. X of t has to be a translated signal. So it has to move towards the left once you have the value of a greater than 0. I repeat, you have to move the signal, okay. So you have to move in such a way that it is being completely at -4 there. What I'm representing this signal as x of t plus 3 will be starting from -4 and will have a peak value of 1 at -3 and will have 0 value at -2 and will have -1, 0 like that. So in other cases, it will be 0 there, okay. So this is the translated signal, that is x of t plus 3, which is V of t, which is said to be the intermediate signal, there. So that is V of t, okay. So now what do I need to write? I need to scale this signal, okay. So I need to scale this signal, okay. So I need to scale in such a way that, just a moment. Okay, yes. So I need to scale the signal y of t. What I need to write? V of 2t, okay. I repeat, so this has to be scaled with the time variable itself, okay. So what you will be getting? You will be getting a compressed version of the signal there, okay. You will be getting a compressed version of a signal. How would you get this compressed version of the signal? So you will be getting it from, so you are having 2 into t, that is V of at. A takes a value greater than 0 here, again you can observe it, and it is not in the like decimals. For example, it is not in 0.5, 0.4 or something like that. It is not in a fraction way also, okay. What you can generally do here is you can have this time instant at -4, this time instant at -2 there, okay. So what you need to do here is you need to change the time itself, okay. So -2, -1 and 0, -1, -2, okay. So this is the value there, and what you need to do when it is 2 here, so once you get t is equal to what would be the value, okay. So what would be the value there? You will be getting the value somewhere around t, which when you give it t as 0, you will be getting V of 0. What is V of 0? That is 0 again, okay. When t is equal to -1, okay, when t is equal to -1, V of -2. So this is V of -2. What you will be getting? It is again 0. When t is equal to -2, what you will be getting? So t will be equal to -4, okay. So -4, again it will be equal to 0 there, okay. When t is equal to 3 by 2, okay. When 3 is equal to -3 by 2, okay. When t is equal to -3 by 2, what you will be getting? So you will be getting V of -3.
V of -3.
Yes, exactly. V of -3. What would be the value of V of -3?
1.
Yes. Where should I write now? Where should I write? Minus 3 by 2 is
minus 1.5.
minus 1.5. So you'll be having a peak here. So this is how I can represent the signal here. So this is the expanded version or compressed version?
Compressed.
Yes, compressed version of which signal? Of which signal? Compressed version of the signal V of t. Sorry, this is V of t here. This is V of t. I have written the compressed version of the signal here, which gives a magnitude of 1 at minus 1.5. So let me write it properly here. So this is how the signal looks like. So 0, this is minus 1, this is minus 2, and this is somewhat here, it is minus 1.5. So at 1.5 with a negative sign, you will be having the peak value like this. Okay, so you'll be having a peak value like this. Okay, so that is what you mean by y of t, that is v of 2t. Okay, so that is t and this one is minus t. Okay, so this is 1. Hope you got it what I've written here. So this is said to be the compressed version of signal which is v of t, that is x of t plus 3. Okay, so that is x of t plus 3. So y of t, okay, so that would be x of 2t plus 3 can be written in this format. So this is nothing but the compressed version of the signal v of t, that is x of t plus 3, can be written like this. Okay, so this is how I can write, or I can apply the precedence rule. So this, you can call it to be the precedence rule here. Precedence rule for time shifting and time scaling. Okay, that is what you can see here. And you can also verify, if you want to verify it, y of 0, okay, that would be equal to x of 3. Okay, so you can see here, so 0, 1, 2 and 3, 1, 2, 3, y of 0 is this one. Okay, x of 3, okay, what you can write it as x of 3. Again, you can see here this signal x of t plus 3. If you can see here, x of 3, what is the value of x of 3 here? So this is also having a value of 0 there. Okay, so that you can verify it. So it has been verified. Next, you can have minus 3 by 2. I just told you right now. So once you have y of minus 3 by 2, that would be equal to x of 0. X of 0, what is the value there? So this is the signal x of t. X of 0 will have the value. Again, you can say this one to be equal to 1 there. Okay, so you can apply it from the original signal. This is the x of t. The signal is said to be the original signal. Okay, so original signal is x of t. So this is the time shifted signal, that is v of t, having an intermediate signal. Next, the compressed version of the signal is this one. So you have 2 steps, and this is the verification step that you are going to follow. Okay, if you want me to repeat it, I will repeat it again. If you want me to repeat, I'll repeat it again, or else we can simply, I can highlight certain things, or I can just go through with the numerical problems.
You want to repeat it, sir?
Yeah, okay. So let me take a signal x of t. This is the signal x of t. Okay, any signal, for example, any signal if you take, I want to realize y of t equals x of 2t plus 3. Okay, let me erase everything. Yes, okay. Now, this is x of t. Hope you are getting. I have written a simple signal x of t where at t is equal to -1 and +1. You are having 0 values, and otherwise also it is 0. Only at 0, x of 0, you are having 1. X of 0, that will be equal to 1 there. Okay. What do I need to do now? I need to realize the signal y of t that is equal to x of 2t plus 3. First step, what do? I create an intermediate signal v of t. How do I create an intermediate signal? That is x of t plus 3. Okay, that is equal to x of t plus 3. Next, y of t, that will be equal to v of 2 into t. That is there. So these are the two signals that I need to realize right now. So what do I do now? First, I need to go for time shifting property. Okay, the President's rule says that I need to go for the time shifting property first. What do I do now? I need to realize v of t first. Okay, I need to realize v of t first. What is v of t? X of t plus 3. Okay, so that is t. Yeah, this is minus t. Okay, now what do I need to do now? I need to see the signal x of t. I need to see the signal x of t. X of t is being moved to the left. What I can see here, v of t, that is equal to x of t plus 3. I can say that a, that is equal to 3, which is greater than 0. Okay, that is what the observation that you need to make. So it is being translated towards the left. So once you are having a greater than 0, translation of signal x of t, translation of x of t signal towards left. Okay, so towards left by 3 units. Towards left by 3 units. Okay, let me mark it 0, -1, -2, next here -3, next -4. Okay, so that is one thing that you need to observe very carefully there. So -1, when it is moved to 3 units towards the left, -2, -3, -4. Okay, next 0, -1, -2, and -3. So at -3 you are having 1. Next -2. Here, what you can observe, 1, 2, and 3. So this is what you can see here. Okay, so if you can see, this is the signal what you are going to get it. Okay, so the signal x of t is translated towards left. X of t plus 3, this is the signal. Translation of signal x of t towards left by 3 units. Towards left by 3 units. Okay, so this is v of t. Hope it is clear to you. Next one, y of t I need to write. Okay, y of t I need to write. Okay, so next step, y of t, that is v of 2t. Okay, so in order to realize v of 2t, you need to look at the signal v of t, that is equal to x of t plus 3. Okay, so y of t, that will be x of 2t plus 3. Okay, again it is the same signal what I need to verify, but I'll be having this one as the intermediate signal. Okay, so this one will be having the intermediate signal, which is the compressed form of v of t. Okay, so this intermediate signal v of t, I know that intermediate signal is v of t. V of 2t is the compressed version of v of t. Okay, so I know that once I write it here, it is the compressed version, v of 3t, v of 4t, 60, 8t, whatever that is there. V of t by 2 is the expanded version. Okay, so now this is the compressed form of v of t. I need to write it. Okay, so what I'll be doing here is, again, I'll be taking the signal v of t. Yes, so this is the signal v of t. What do I need to write it now? I need to ensure that I'll be having v of 2t being written there. Okay, so what is to be done? So when t is equal to 0, okay, -1, this is -2, this is -3. Okay, this is minus 4, this is minus 5, okay. Yeah, so this is minus t and this is t here, okay. So now what do I need to write here? So this is minus 4 that is there. What do I need to write it? I need to have the signal v of 2t being written, okay. When t is equal to 0, v of 0, what is the value? That is 0 there. Next, t is equal to 1 by 2, okay. T is equal to 1 by 2. What happens here? V of 1 by 2. So again, this one here, that is 1, okay. V of t, that is when t is equal to 1 by 2, okay. So when I put t is equal to 1 by 2 here, so you will be having v of 1. So v of 1, what is the value of v of 1 here? Okay, that is equal to 0. Yes, exactly. So next, what do I need to do? I need to take the other way. That is when t is equal to minus 1 by 2. Looking at the signal, I need to identify, okay. What happens? V of minus 1, okay. What is v of minus 1 here from the signal?
0.
That is equal to 0 there, okay. So this will be having a value of 0 again. Next, v of, I need to take minus 2. What I need to do here now? Yeah, what do I need to do? V of 2 into, I need to get the signal as t is equal to minus 1. T is equal to minus 1. When I put t is equal to minus 1, what do I get? V of minus 2. So v of minus 2 I need to put. I mean, when t is equal to minus 1, I'll get v of minus 2. What is the value of v of minus 2?
0.
Okay, 0. Okay. So again, it is 0 here. Next, what do I need to check now? When t is equal to minus 1 by 2. Yeah, minus 3 by 2. Correct. Minus 3 by 2. What is the value? That is v of minus 1.5.
Minus 3 is equal to 1.
Yeah. Yes. So this is the value, that is minus 3 by 2. That is there. What you will be getting here? So once you will be having minus 3 by 2 minus 1.5. Okay. So the value t, once when you put t is equal to, just a moment, v of minus 2 is there, that is 0. Next, you will be getting minus 3 here. Okay. So what is the value that you are going to put here? That is when it is minus 1.5, that is you will be having a magnitude of the value, that is, I'm sorry, here I need to write, that is the value which is said to be 1. Next, the other value what you are going to get there, it is the minus 2. So this is somewhat like this, and this is equal to 1. So you need to change the values here. Hope you are getting what I'm telling right now. So you need to give different values of t and then check the next values. Okay. So for example, when v of 2t is there, right? So when t is equal to 0, that is equal to v of 0, that is the original equation, that is again equal to 0 there. Okay. When v of 2 into, when t is equal to minus 1, okay, that is v of minus 2. What is v of minus 2 here? That is equal to 0 here. Okay, when t is equal to minus 1, that is equal to 0. Next, v of 2 into minus 1.5. Okay, minus 1.5. It takes, that is 1.5 can be written as 3 by 2. Okay, 3 by 2 with a negative sign. We will be getting v of minus 3. Okay, that is v of minus 3 when t is equal to 1.5. So v of minus 3. What is the value here? At minus 3, you are having
1.
a magnitude of 1. Okay, so this is 1.5 with a negative sign. Next, v of 2 into, again I'll take minus 2. Okay, so t is equal to minus 1 here, minus 1.5, and here minus 2. So that is v of minus 4. That is equal to 0 here. Okay, so hope you are getting what I'm telling right now. So the same step what we did, if you could realize in even and odd signal, the same way you are doing here. Okay, so this one is said to be the compressed form of compressed by 2 units. Okay, compressed by 2 units of signal v of t. Compressed by 2 units. Yeah, compressed by 2 units. Compressed by 2 units of the signal v of t. of the signal, that is V of t. Okay, so this is what you can verify in this equation or the signal that I'm sketched here. I have sketched two signals here, so you need to verify whether the signal what is being written, that is y of 0 equals x of 3. What is the value? Now, what is the value of y of 0? I need to verify, verification has to be done. Y of 0 equals x of 3. What is the value? Anyone? Then y of minus 3 by 2, that will be equal to x of 0. That will be equal to 1 then. Okay. So that is what you can verify from this equation. Okay. So this is the verification step that you are going to do here. So this is the verification that you are going to do here to ensure the precedence rule is carried out. Okay. We will stop here right now. Okay. We will stop here. Meanwhile, I'll be sharing you the numerical problems of this precedence rule and time shifting and time scaling. I'll share two problems, one with the discrete one and the other one with the continuous time one. If possible, you need to try it, and in the next class, any one of you can let me know how to proceed with it, and in the next class we are going to have the same discussion being carried out. Okay, if you have